Okay, so now we have the factor theorem, and the factor theorem says two really important things. First of all, if you do an evaluation, you take f of c, and it equals 0, then means the remainder was 0, right? So that means that it divides evenly. It means that x minus c, oops, that's supposed to be a c, and I'm thinking that we'll put parentheses around it. X minus c is a factor. It's a factor of the polynomial. So remember when we were solving quadratic equations in the past, it was easier if we could factor the equation, and then we could find the zeros that way, right? Using the zero product principle. Okay, so if you do, f of c, you synthetically divide and the remainder turns out to be 0, then you know a factor, and the factor is x minus c. The other thing says if x minus c is a factor, so you know a factor, then f of c equals 0. Okay? So it's saying two things, just, two different ways. Okay? All right, and we're going to show you in the example how this is going to work. All right, so it says solve this equation. So it has an equation, and we want to think about finding the zeros of that equation, like what x values would make that equation true, okay? And it's third degree, so we can't use the quadratic formula. We can't use any of the quadratic methods because the degree is too high. But they tell us that 3 is a zero of that. So that means f of 3 is equal to 0. So if I synthetically divide 3, it's my c, okay, so this is c, and I use those coefficients, there's enough coefficients, there's no missing terms, so 2, -3, -11, 6. So I should be able to divide this and know that the remainder is going to be 0, right? All right, so bring down the 2. 2 times 3 is 6. -3 and 6 is 3. 3 times 3 is 9. -11 and 9 is -2. -2 times 3 is -6. Voila, it turned out to be 0. We knew that. It told us 3 is a 0, right? Okay, but here's the great thing. Now we know that f of x is equal to x minus 3 times something. And there's no remainder because we just divided it and there was no remainder, right? This is a remainder of 0. Okay. What is this something? Well, we know the quotient. This is the quotient, right? And we know it. It's right here from the coefficients. It's going to be 2x squared plus 3x minus 2. So I now have f of x is equal to x minus 3 times 2x squared plus 3x minus 2. And I'm trying to find when does that equal 0. I'm trying to find the zeros of the polynomial. I'm trying to factor this. I'm trying to find what values of x will make that 0. Okay, we did this one. We know 3 is 0. They told us that. Okay, so solving the equation, we know one of the answers is 3. Okay, that's a 0 of the equation. We know that's one of the solutions. Now we just have to set this equal to 0. So when does this quotient, when does that equal 0? Okay. Now you're going to do that by factoring, or you could use, this is quadratic, so you could use a quadratic formula, whatever method you want. I think it factors, so I'm just going to go with the AC method. So what multiplies to be -4 and adds to be 3? I'm thinking 4 and -1. So here I go with my factoring. And I draw the dotted line. It's a grouping thing now. Factor out a -1. So if you didn't want to factor, you could use the quadratic formula. So whichever way you like better. Okay, and now we know what the zeros are going to be. When does x plus 2 equal 0? This is back to the zero product principle. Whoops, 2x minus 1. So here you're going to get x equals negative 2. And here, if you put the 1 on the other side, divide by 2, you get x equals 1/2, right? Okay, so the solutions, or the zeros of the equation, are 3, that one they gave us, and negative 2 and 1/2. So there were 3 solutions, and those are they. It means that polynomial f of x, that was equal to x minus 3 times these, x plus 2 times 2x minus 1. So see, I have linear factors here, and I got them all factored, and I was able to find the solutions, 3 and negative 2 and 1/2, based on the zero product principle. So hopefully you think that's pretty cool. But that is the factor theorem right there. Okay.